What we're going to talk about now is called apparent wind. And I'll show you how to calculate this eventually. But essentially what this is, apparent wind is the wind you feel because you are moving through an atmosphere. That's a nice general definition. And essentially you can use this an idea that well, I don't know, let's say you're on a platform with wheels, and here you are, and you're just there moving. You're moving this way, and as you move through the atmosphere you feel an apparent wind. Okay? So the apparent wind in this case, let's say you're moving I don't know, 5 miles per hour this way on this little cart, and the apparent wind is going to feel like 5 miles per hour. That's what you feel in your face. And the assumption is that while you're doing this, the assumption is there is no real wind blowing. So what you feel then is yourself moving through the atmosphere, and in the direction you're facing, which is the direction you're traveling, you feel a wind against you of 5 miles per hour, which is as fast as you're going. Now anything that moves through the Earth's atmosphere, any atmosphere, any fluid, is going to feel this reaction, this apparent wind. It only exists because of the motion of the object. So here you are, you're on your sailboat, and it's moving along, and here you are, got the little rudder there, and this sort of looks like it's in irons at this point. Okay, let's say there's a real wind, and the real wind, and you're now moving into the real wind. All right. And of course, if you're in this situation where you're luffing and the real wind, let's say, is blowing at 5 miles per hour from some direction, and you're directly into the real wind, then your apparent wind is going to be the speed you might be going this way minus this particular wind. For example, let's say you're moving along in that direction at 10 miles per hour, which is pretty fast. You might have some pretty long boat there, right? So the apparent wind will be the difference between the boat's speed minus the real wind, the real wind's speed. So in this case, the apparent wind will equal the boat speed, 10 miles per hour, minus 5 miles per hour, or 5 miles per hour. And that's the apparent wind. We'll call it AW. Okay. So that's the intuitive nature of all of this. And if we want to, we can place the boat on a coordinate system graph. Okay. And you can have the real wind moving toward the boat and the boat moving, the boat speed moving in that direction. Right? So there's the real wind speed. And what do we have? The real wind was what, 10 miles per hour, and the boat is 5 miles per hour. And you can see that when you have this situation where everything is sort of in the same line, then it's a simple algebraic subtraction, and what's left over is the apparent wind. So you feel a wind of 5 miles per hour. Well, as it turns out, the apparent wind, mathematically speaking, is actually the resultant, from a math point of view. The apparent wind is defined as the resultant when you add the boat's speed to the real wind, the real wind's speed. And we can call the real wind the true wind. Okay. Now what's important to know is only when the boat happens to be moving either directly into the wind or directly opposite the wind can you actually use the equation in its algebraic form. In other words, add things as you would expect. But here we have a different word that we've got to deal with, and that word is resultant, which then implies we're not doing algebra, algebraic addition. All right? The apparent wind the true wind and boat speed are vectors. So things are a little bit different, and we're going to have to deal with vectors. And I will define them for you in part 2. This is the end of